Hi, you are watching channel Mr. Electron, and these what you see are a few broken or damaged mobile chargers. So today in this video I'm going to use them to make a 12 volts power supply for charging my batteries. So guys, these are a few 5 volts mobile chargers that I have salvaged. Let's test them. So guys, here as you can see that I'm connecting the mobile charger circuit to my 220 volts home socket power supply. Now let's test it with an incandescent bulb. Although the voltage is not 12 volts from the mobile charger, but still it is glowing. A little dim, but yes, it is glowing. So this one is fine. Now let's test this one. Working. Working. So all of them are working, and now I can connect them all together. Now this what you see is an old dead 12 volts 8 amperes power supply SMPS, and because it's dead, let's open it up, remove the circuit and reuse its case. As you can see, the transformer shows the rating 12 volts 8 amperes. So guys, I've cleaned up the box as much as I could, and after that I also thought about repairing this circuit board which was damaged. So fortunately there was a minor problem. This was the capacitor. You see the top part of it, it seems a little stretched, and you can see that the cover also got stretched, and this was the piece of it that told me that it was 100 microfarad. You see 100 mu f and 450 volts. That's what I took from it. So what I did was, instead of the 450 volts capacitor, I used a 400 volts and 82 microfarad instead of 100 farad. And guess what? That was the only problem, and it started working just fine. Also, I took the capacitor 400 volts and 82 microfarad. You see 82 mu f 400 volts from this slot. And this is another circuit that was lying around, not in use. So let's test this one first. Okay, so let's turn it on and see how this 8 amperes power supply performs. You see the light has started glowing and there is no blast. So here what I have is a bike headlamp bulb. You see 12 volts 35 watts. So let's connect this one first. Yeah, you see it's glowing pretty bright. And here I have full 100 watts bulb, 8 amperes. You see 12 volts 100 to 90 watts. So let's connect this one, and this should be even brighter. Oops, power supply is turned off. Maybe it's not handling this kind of load. Maybe it's old. Let's try by simply switching. Yeah. Oh, it is so hot. Yeah, now it's working. Once again with my lab lights turned off. See, it's so right. Oh, it's very hot. Now let's also measure the current at the same time. And we did a max of 8.68. Wow, and the supply is working very nice. Now let's test my high current drone motor. Wow, nice. And guys, now that the power supply is working great, I can no longer use the box for my mobile charger 12 volts power supply project, and I will have to use something else for that. So let's place it back as it was before. So guys, now that I have packed it successfully, let's turn it on. And yeah, you see here the red light indicator, it's working now. Car headlamp night eye. Wow, nice. And now for my mobile charger circuits, I'm going to use this PVC case. There were too many stickers on it, so I had to like grind it. Okay, and the case is just fine for my circuits, and these two can go the sideways. Okay, so guys, here as you can see that I've placed all the circuits on the walls of the case, and I've fixed them with screws. You see this one, same for this one, and that one, and it is quite strong. It's not gonna come out. Now let's start with the parallel connection of this side of each circuit, like the 220 volt side that is going to be connected in parallel. So guys, here as you can see that I've completed the soldering part for the 220 volts high voltage side, and here I've used the heat shrink tube for covering it up for safety. Looks quite nice. Now let's connect this cord to the 220 volt socket and see if each individual charger is getting supply. So all of them are getting the 220 volt supply. Now let's connect the outputs together. Now guys, here as you can see that there are 4 power supplies or mobile charger circuits, and because this one and this one, these two are a little weak circuits. I mean, they're going to produce only 1.5 amperes each. So I'm going to connect this one and this one in parallel to increase up or double up the current, and this one is good enough on its own, so is this one. So these two in parallel, and then this set will be connected in series with this one and this one. And you see the bulb is glowing really bright this time because all the chargers are working together to light up one single bulb, and the voltage is quite high, really nice, very bright. And not just that, it can even power up a car headlamp bulb. This is, yeah, here it's written 12 volts 55 watts, so it is quite a strong bulb. You see, it's glowing really bright. Very hot from this side. So let's pack it up, take out 2 wires from the box and then cover it up.
Next level. Next level.
Guys, that's the plastic cover that I've just made. So let's check the voltage that it is producing, and here as you can see it's 15.5 volts DC, which is quite high for charging a 12 volts battery. We need around 14.8 volts. So guys, now I'm going to use this 6 amperes diode to create a 0.7 volts drop because the voltage produced by the power supply is 15.5 volts. So 15.5 minus 0.7 will make it 14.8 volts DC, which is best for charging our batteries. So this side of the diode is positive and the silver side or gray side is negative. So the positive side has been connected to the positive white wire, and this one will be connected over here. But before I do that, I will have to connect this metal sheet, which is going to act as a heat sink for the diode. Although the current is not going to be much high, but still there is a possibility that's going to heat up. Although you can do the same process by placing the diode inside the box, but I'm not doing that. So guys, finally the project is complete. Now let's test it with our battery. Now guys, this is the parcel that I got from Loom Solar, which is one of the biggest solar panel manufacturing company in India, along with batteries and their charge controllers. So if you want to have a look at their website, link has been provided provided in the description. So as you can see guys, that it's a 12 volts battery which looks quite similar to a UPS battery. The current rating as you can see is 12 ampere hour with an expected lifespan of up to 10 years and 24 months of warranty, making it 2 years. Now the best part about this battery is that it's made of lithium iron phosphate cells, therefore larger lifespan. Now if we have a look at its battery voltage, so as you can see they have charged it at 13.37 volts. So guys, here I've connected the power supply to this battery and the multimeter is showing the battery voltage at present because I have not turned on the power supply yet. So when I'm going to turn it on, the voltage on the multimeter should start increasing, indicating that everything is working fine. Okay, so turning it on. So the voltage has started increasing and our battery has also started charging, and it is going to go to a max of 14.8 volts when the charger is going to cut off, indicating full charging. So here we have reached 14 volts and increasing. Super strong. Thrust is too high. The battery is really powerful. Hi guys, you are watching channel Mr. Electron, and these what you see are a few 12 volts DC motors. Now a DC motor is a variable current type of load, which means that the current keeps on changing as the load changes. Higher the load on the motor shaft, more is the current drawn by it. Next, what you see are a few incandescent bulbs which come under the category of constant current type of resistive loads. And the final ones that you see are the constant voltage loads, which are our electronic circuits and batteries. Now guys, all the above loads are rated at 12 volts, but let's assume that I only have a 20 volts 3 amps DC source. Now what will happen if I connect the previously shown loads to this higher volts supply? In case of the DC motors, their no load speed will increase because RPM is directly proportional to the input voltage. The impact will be its brushes will wear out faster than usual, its commutators will also wear out faster than usual. There is also going to be an additional heating which might affect the strength of magnets used in the motor. Now let's consider the case of what will happen if we connect a 20 volts supply to a 12 volts 1 amperes bulb. The bulb will fuse instantly because more than rated current will flow through the filament and burn it. Now comes the final test of connecting the 20 volts 3 amperes power supply to a 12 volts electronic circuit or a 12 volts battery. Both of them will get damaged because the battery will get overcharged with time and the electronic circuits are too much voltage specific. So keeping all that in mind, we can conclude that we need to build a 12 volts circuit. Let's get started. First component is 13009 power transistor, second one is CTC1351, third one are diodes, Zener diodes, 1.8 volts each, and the fourth final one is 1 kilo ohm resistor, and final heat sinks and few wires. That's it. Now comes the construction of the circuit. Take the 13009 power transistor and bend its 3 terminals as shown. Next, do the same thing with the NPN1351 power transistor. Next comes the placing of thermal paste or heat sink compound on the power transistor. Okay, this is how it is going to transfer all the heat safely to the heat sink. Place it on both the transistors. Now comes the part of mounting the two transistors on the heat sink. So here, as you can see, that I'm going to use a single heat sink and I'm going to mount both the transistor on a single piece. You can use two heat sinks, separate heat sinks, for cooling it further, but I think it is not going to generate much of heat. Now take the two Zener diodes and shorten up their terminal ends by cutting them. After that, connect the two Zener diodes in series. Like one Zener diode is at 1.8 volts. So if we connect two of them together in series, it's going to be 3.6 volts DC. Now take the positive end of the Zener diode and connect it to the base terminal of the 1351 power transistor. Now solder the base of 13009 power transistor to the emitter of 1351 power transistor. After that, take a wire and connect it to the emitter terminal of 13009 power transistor. Now comes the collector terminals of both the transistors. These two collector terminals will be soldered together, and this point is going to be the tapping point at which multiple connections will be made. Take another wire and connect it to the collector, common collector of both the transistors. Now bend the Zener diodes and connect their negative set to the collector as well. This is how you're going to do it. Now hold the green wire as shown here and place it through the screw hole of the heat sink. Now you will need another wire, a different colored one. Strip it and then place it through the other screw hole of the heat sink. Lastly, strip the two wires in the middle and connect the 1 kilo ohm resistor to the two wires. Please note that the links for all the needed components have been provided in the description, so don't forget to check them out if you really want to make this circuit. So well done guys, it's finally time to test it. This is the laptop charger connected to the 220 volts supply, and this laptop charger is converting 220 volts AC to 20 volts DC. So what I'm going to do is convert that 20 volts DC to 12 volts DC, although the output is going to be a little higher so that there is a charge difference and current can flow easily. And remember that this green wire here is positive and yellow one is negative. Red clip will be connected to the green because red is always denoted by positive, and yellow one will be negative, and we are done. Now let's do the measurement of output voltage first. So pointing the meter towards DC voltage measurement mode. Okay, you can see there is some voltage being deflected because of one wire connection. And now we have our full 13.09 volts DC out from the laptop charger by using just this circuit. No transformer is needed. All you got to do is just do this. It is very simple and safe, and the output voltage is pretty accurate. So the voltage testing is done. Now comes the LED panel glowing test. So this is a 12 volts LED panel, and obviously it would have burnt out or got fused if I had connected this panel directly to the laptop charger, since this is 12 volts and this is 20 volts. So I have converted it safely to 12 volts. Let's see how it performs. And here we have 20 volts beautifully converted to 13 volts, exactly needed for this. Let's turn off the lights. All the lights have been turned off, and you can see that it is glowing really bright. And also there is negligible heating because this driving transistor is rated at 12 amperes and also connected to a good heatsink with heatsink compound or thermal paste, so it should not be a problem. Turned off the camera lights as well, and now it is even more bright. See, pretty good, right? So let's increase the loads now. This is a 12 volts 35 watts bike headlamp bulb. Let's try this one. Let's turn off the lights. You see, it is glowing pretty bright. Moving on to an even bigger bulb, you see 12 volts, 100 watts. That's big one for car headlamp. Let's turn off all the lights. Now guys comes this high current DC motor. It is 12 volts, 5 amperes, really smooth. So let's test this one. Initially it was running on 20 volts, so the RPM was higher, but now it is running at the exact needed RPM. So guys, I have removed the jumper cables and I have connected the circuit directly to the laptop charger. Meter is showing 0 volts DC, and let's measure the battery voltage, which as you can see is around 12.54 volts. Now let's connect the jumper cables here and then see the change in voltage. At present it is 12.54 volts and you can see that it is safely increasing. And we can leave it like this. So guys, your question for today is, what was the maximum RPM displayed by the tachometer in my previous project video? Well guys, you can also carry out the same process on a 20 volts solar panel. Okay, that's the battery meter and my circuit. Here as you can see guys, that the voltage is increasing. 12.47, 48 and so on. So the increase in voltage is indicating here that the battery is charging with the solar panel, and it is really safe because this circuit is going to limit the output voltage to around 13.2 or 13.3 volts DC. So you can even leave the battery so that it keeps on charging all the time, and when it is fully charged, then the current from the circuit is automatically going to reduce to zero. Hi, this what you see is a manual desoldering pump. So today in this video, I'm going to convert it into an electric pump. Now this is a high temperature sleeve and I have used it in between the desoldering pump tip and the nozzle. Now this one is another high temperature sleeving, but it is very thin, and this is my heating filament from an old damaged heater. So I've taken a little wire out of it. So what I'm going to do is use this filament and slide it inside the sleeve carefully so that I don't accidentally break it. So I'm going to leave this much and it's going to be useful afterwards. Now we are going to need another thin metal wire. It is not a filament, but it is going to hold this filament or heating filament strongly on the tip. So let's take it out a little more and start with this. Now if you look closely, I'm doing it only at this end and not at the rest of the portion. And then turn it like this. Done. Now press it like this on this side. Now comes the sliding of the sleeving back again as much as possible. Yeah, next comes winding it like a coil. So I'm going to operate this newly made electric desoldering pump at 12 volts. This time I'm going to use this 12 volts transformer. You see 230 volts to 12 volts. It's around 3 or 4 amps. DC, AC, RMS, true RMS. Turning it on, and here we have 3.5 amperes. You see smoke. That's the close-up. Now we need to test it. It's consuming around 46 to 50 watts. So here is a circuit board, and you see this capacitor, one of its leg is broken. So I'm going to remove it because I have to repair this power supply also. So that's the end point of it. Okay. So the supply has been turned on. Let's charge it. Done. Whoa. Oh, you see, I'm pushing this piston and it's doing like this. Pretty cool. So anyways, charging it once again. Wow, that was nice. Once again, you see, it actually desoldered and the capacitor is out. Brilliant. So yeah, our electric desoldering pump is working good. Well guys, the setup is working really nice, except that there is one problem. I'll show you. You see, it's getting all like wobbly. The plastic is not strong enough to hold that high temperature. I think I will have to modify the desoldering pump, then only it is going to work. I mean, it is going to be a perfect piece. So let's do that. We are very close. So the first thing that we need is a soldering iron. Well, I had this piece lying around for many years, so I thought about using this in this project. So I'm going to use this heating filament from the soldering iron in between the desoldering pump and the metal tip that I just made using my lathe machine. And the sole purpose of using this part from the soldering iron is to prevent the high temperatures that are going to develop on my newly made tip from transferring to the plastic parts of my desoldering pump. Now guys, I've done two changes. First one you can already see is the power supply. I've removed the transformer and I'm going to use this 12 volts 8 amperes power supply this time, and I'm going to turn it on. See, red light glowing, so it's on. Now to the desoldering pump, I have added another step. Now initially this piece that you see, this was connected directly through this black piece, so it was heating a lot. So I have created another step. I have used this white high temperature PVC sheet and then another metal piece, brass piece in between to create a further step for heat distribution. Plus there is another final change, which as you can see is the brass tip that I made using my lathe machine. Now the video was getting really long, so I didn't include the parts in between, but I have explained to you all of them in detail. Yeah, it's working okay. Brilliant. Wow. Now it's working great. Once again. Cool. Now I have to desolder these 3 points also, because for placing of the new capacitors I will have to remove the remaining legs. So guys, here as you can see that I have covered the joints with the high temperature sleeving and it looks quite nice this time. And guys, I also wanted to introduce you to a new member of my workshop family, this beautiful toolbox manufactured by Build Skill. And I also like the color combination, it is so amazing. And as you can see that it opens quite easily and it has 5 compartments, with 4 being medium compartments and one a really big compartment, the lower one. And guys, the best part is that it is really strong. It is made of steel and it is quite big, so it's very spacious for all of my tools. So guys, if you want to buy it, link has already been provided in the description. You can check it out.